So we've just been discussing this function x squared plus 3x plus 4, and I asked the class, what does the graph of the following function look like, and how do you know? And they told me that this was a parabola, and that it opened up. And that we knew that it opened up because the leading coefficient, or the coefficient in front of x squared, was a positive number. And they knew that it was a parabola because when we looked at whether this exponent here on this leading term was odd or even. If it's even, we know that the two ends of our function have to sort of tend off in the same direction. Okay. So we've been working on this since grade 10. You did a lot of this in advanced functions. Let's talk about this in terms of limits a little bit. When we're talking about limits involving infinity, and we're looking at polynomial functions, really what we're talking about here is the end behavior of the function. How does this function behave as we go to very, very large or very, very small values of x? So we're interested in what happens as x tends off to either positive infinity or negative infinity. What is our function going to do? Is it going to go up, and without stopping, i.e. tend off to positive infinity in the y direction? Or is it going to go down without stopping and head down to negative infinity in the y direction? Well, we can get a handle on this using limits. So let's say if we're interested in what happens for very, very large values of x, we're looking at taking the limit as x tends to positive infinity of our function. And we can imagine evaluating this function just by subbing in positive infinity for x. Now this is a little bit weird. You can't really sub in positive infinity for x, but you can kind of imagine what would happen to the individual terms of your function if you did sub in positive infinity. So let's just pretend that we're subbing in positive infinity, and I'm going to use these square brackets that are kind of like we're just pretending here, all right? So if I sub in positive infinity, I get positive infinity squared plus 3 times positive infinity plus 4. Okay. And then we kind of imagine which of these terms, how these terms are going to behave. Well, the first thing I do is, it doesn't matter what this last term is doing. It's just a 4. And 4 is really, really small compared to infinity. Okay? So what this last term is doing, this constant term is doing, because it doesn't change as we change the value of x, we can kind of ignore it. So this term here, in this 3 times positive infinity, suggests that our function is going to go off to positive infinity. This first term here, if I do positive infinity times positive infinity, well, I've got a positive times a positive. That, again, is going to give me a positive infinity. Okay? So these first two terms suggest to me that I'm going to end up with the first term going off to positive infinity, the second term going off to positive infinity, the last term we don't even care about. So all in all, this limit is going to tend off to positive infinity. So our function is going to, as we go this way, off to x goes to positive infinity, our y value is going to go up to positive infinity like that. So our function is going to head off like that, up to the upper right quadrant there. Well, what if we're interested in what happens as we go the other way, if x is going towards negative infinity? Well, again, we can imagine what happens if we think about putting negative infinity into our function here. We get negative infinity squared plus 3 times negative infinity plus 4. Once again, we ignore our poor old 4 because it's not going to tell us much compared to our infinities. Okay? This term here suggests that we're going off to negative infinity because 3 times negative infinity is like a negative infinity. This first term, though, if we've got a negative infinity times a negative infinity, negative times negative is going to give us a positive infinity. So this term suggests we should go off to positive infinity. The second term suggests we should go off to negative infinity. Well, which one are we going to believe? The answer is that we believe the one that has the higher power, because it's going to change a lot more quickly than the one with the lower power. Infinity squared is going to get to infinity faster than just straight infinity. Okay? So we always look at what the larger exponent is telling us. So this one, again, is also going to tend off towards positive infinity. We don't need that. So over here, this thing is going to head off to positive infinity as x tends towards negative infinity, which gives us, if we just join up the curves here, our nice little parabola shape here.